Alright guys, so hello Nazma. I hope that you're able to see and hear me properly. Yes. Alright guys, so today we are going to have this session, previous year question solving session on carbohydrates and the amino acids. Alright, I hope that you're able to hear me clearly. Yes Nazma? Okay, so see, yes, so again let me just tell you that we are going to study carbohydrates and amino acids. Alright, and before we begin the class, so let me tell you a little bit about myself. My name is Jagriti Sharma and I'm an educator on the Unacademy Plus platform. Alright, and if you have already visited my profile, then you must know about my courses also. But if you have not yet visited my profile, I would suggest you to go on Unacademy home and you can type my name over here, Jagriti Sharma, and you can search for it, and you will be able to see all my courses which are running, the special classes which I have taken previously and the upcoming ones. Alright, and guys, for those who have not yet followed me, I would suggest you to follow, because when you are downloading the app, okay, so if you have downloaded the app, there will be a follow button right over here. Alright, and if you are on the website, then also there will be an option of the follow right over here only. So if you are following me, you will be able to get regular updates. Okay. And guys, these are my courses. Okay, so these are the plus courses that I have shown over here. Right now I'm conducting 2+ courses, capsule course on inorganic chemistry. So in the inorganic chemistry course, we are talking about the organometallic compounds, the bioinorganic chemistry, the coordination chemistry. All right, and in this crash course on organic chemistry, I have tried to complete everything from the beginning. All right, so from the beginning I had started, and now we are on the spectroscopy. All right guys, now we are studying spectroscopy. So these two are my plus courses, ongoing plus courses. And guys, I would suggest you to, if you are watching the video for the first time, then I would suggest you to go and also click on the special classes, because what is a plus course? A plus course is a regular course, right? It is a regular courses with regular classes on the same time. All right, daily same time, so like that. And special classes are live classes. Okay, they are also very similar to the plus classes, but they are free, and they will also be recorded on the platform, right? So my previous special classes are also recorded on the platform, so you can just go and watch them, and most of them were focused on previous year question solving. If you go and watch, you will realize, and they will be very very helpful to you, as I can yeah. So yes, so previously taken a special class also you can see. And guys, and one more thing, you will also be able to see my upcoming special classes. So upcoming special classes, or basically free live classes, are on the practice session on natural products, then practice session on heterocyclic compounds. So basically I've taken 2 classes on heterocyclic compounds, right? 2 practice sessions. So these are my upcoming classes for the first week of December, and you can just go and register for them, because if you want to attend those class, you just have to register, nothing else. You just have to download the Unacademy, or let's say even if you are not downloading the Unacademy app, you can just register on the website as well. Okay, and you can register from this link directly. Okay everyone, so these are my upcoming special classes. The YouTube classes which are left or basically the upcoming YouTube classes are on these topics. Previous year on previous year questions on organometallic compounds, and also previous year questions on organic spectroscopy. So these are the two YouTube classes that are left for this month, because the month is also ending, guys, isn't it? And today we are having our previous year question on carbohydrates and amino acids. All right. Okay, and let me tell you one more thing, guys. If you want to have the subscription package, so we are having the subscription package 1 month, 3 months, 6 month and 12 month, also 24-month subscription package. So guys, let me also tell you that from January 2020 we are starting whole new courses, okay, for the preparation of 6-month preparation for the June 2020 exam. So if you are serious about your preparation, then I would suggest you to take a 6-month subscription plan, or let's say a 1-month subscription plan if you take it right now, because in the month of December, as I had already announced, from 2nd of December I'm starting a whole new practice course. So in this practice course, it is basically called 200 practice questions for maximum marks. So I am going to cover 200 minimum questions. It can be more than that also. Okay, so in those classes we will go on practicing maximum questions on the 2nd of December. So guys, if you want, you can take one of these 6-month or 1-year package. That will be best if you are considering June 2020 also. Alright guys, and whenever you are applying, or let's say applying for the subscription, you are taking the subscription, always remember to apply a referral code. Do not pay without using a referral code, because let's say if 10,500 is the fees for 12 months, then after applying my referral code, which is Jagriti S, it is going to reduce by 10%, and it is only going to be 9,450, right? So this is my code, guys, Jagriti S. It is JAGRITIS. All right. Okay everyone, so now we are going to start our class for today. So we are going to start solving our questions. So the first question that I've taken is from December 2015, and it is a very nice question, guys, from the it's a very nice question from December 2015 from carbohydrates. So the first question is, D-mannose upon refluxing in acetone with copper sulfate and H2SO4 gives. So basically the question is asking what will happen if we are refluxing D-mannose in acetone and copper sulfate with H2SO4. Alright, so this is the structure of D-mannose. So the question has already given you the structure of D-mannose. You just have to tell me the correct answer. Yes, alright. Alright, so is anyone going to tell me the correct answer? Yes, Nazma. This question was asked in December 2015. All right. Okay. So what can we say about this is that if we are having acetone, so in yesterday's plus class we had just studied that whenever we are having acetone and whenever there is a sugar we are having, then definitely the sugar is going to form basically the acetone is used for the protection of, it is used for the protection of 1,2-diols. It is used for the protection of 1,2-diols. All right. So that is why we can say if acetone is used over here, then definitely it is going to search for the 1,2-diol in the carbohydrate system. Yes, it is going to search for the 1,2-diol in the carbohydrate system. All right. But look over here in the structure of D-mannose. Look over here. we are having 1,2 diols like this. So this is one of our 1,2 diol, one OH over here, one OH over here. They are perfect for the formation of acetal, right? So basically what is happening, this is our CH3, C double bond O and CH3. So with 1,2 diol, with 1,2 diol system, it is just basically giving us acetal. All right, it is just giving us acetal system like this. Okay, so now what we need to do is we need to find out 1,2 diol system from here. So these are our 1,2 diols. Also we are having these two diols as 1,2. But guys, as we can see that this one is equatorial and this one is axial, right? One of the OH is equatorial, one of the OH is axial. So in the axial equatorial position, it will be very hard for the molecule to form the 1,2 diol. Then what is the way out? Do we have anything else? Do we have any other option? Let's see. So in the options, as we can see, the molecule can also form furanose ring, isn't it? It is given in the options. It can form furanose ring. What is a furanose and a pyranose ring? So guys, a pyranose ring is basically a 6-membered ring over here with oxygen in it. Okay, so this is our pyranose structure. Okay, and when we are having a 5-membered ring with oxygen in it, it is called furanose structure. And as we know, as we have discussed yesterday only, that the D sugars that we are having, the D sugars which we are having, it can be glucose, it can be, right, it can be glucose, it can be mannose, it can be galactose, and so on, right? So what can happen over here is that, so if you are having D mannose like this, okay, so it is our furanose ring structure, right? So I have just written my pyranose form. This is our pyranose form, 6-membered ring. So I have just written pyranose form of D mannose like this. Okay, 2 of the oxygens above the plane, one is equatorial, one is axial. So I've just written it over here like this. One OH below the plane, okay, one OH above the plane. Basically this is CH2OH. This is our CH2OH. So again CH2OH above the plane. Alright, and we are not talking about the alpha and beta anomers, so I've just kept it a wiggly line only. Alright, so what can I see is that whenever we are having acid in the medium, there is a possibility of ring opening. There is a possibility of ring opening and closing. That, as I can see, that this OH is below the plane, and if the ring opens from this side, then what will happen? Then this OH can actually connect with the oxygen over here. So this OH can form the hemiacetal linkage. So guys, if we talk about the structure of D mannose basically, okay, then what we see is that, if we talk about the structure of D mannose, what we see is that it is basically, if we are talking about this, alright, so if we are talking about the structure of D mannose, it is a C2 epimer of glucose, isn't it? If our glucose is like this, if this is our glucose, then mannose is a C2 epimer. What is a C2 epimer? Only the OH at carbon number 2 is going to get changed, okay, right? So mannose over here is the C2 epimer of glucose. So as we can see, the pyranose ring forms, the pyranose requires 6 number of atoms, right? So if this oxygen over here is combining with this carbonyl, right, then the 6-membered ring will form. 1, 2, 3, 4, 5, and the 6th is our oxygen, right? Then the 6-membered ring will form. But if I am taking Just a second, guys. Okay, so if I am taking okay, so if I have taken carbon number 4 CH2OH over here, so if I am taking this OH group, right, if I am taking this OH group and if it is bonding with the carbonyl carbon and it is giving the hemiacetal, okay, if it is giving the hemiacetal, then it would be 1, 2, 3, 4 and 5. So that will be our furanose ring, isn't it? So what we need to do is we need to open up this bond, this sixth OH group and CO bond, and we need to form the fifth OH and CO bond over here, right? So this is what we want. We need to open up the pyranose form and we need to make the furanose form. Okay, so I hope that you are able to see the furanose form, and if you are not able to see, let me just write it over here on this side for you. How am I going to form the furanose? How is the ring structure of furanose looking like? Then it will be very easy for you to understand the question as well. So let me just write it over here for you guys, because I think that it is covered by my image, my video playing, right? So I'm just writing it over here for you guys. OH on this side. Definitely not talking about the anomeric OH because it does not matter much. Alright. Okay, so now after forming the furanose ring, now we can see that these two oxygens, basically hydroxy groups, are becoming one of our 1,2-diol systems. Yes, and these two are also becoming our one of the 1,2-diol system, and both of them are above the plane like this. Okay, both of them are above the plane like this one. Alright, and that is why whenever we are giving acetone, we know that acetone is going to protect the 1,2-diol system. Okay, and that is why now it is covering these two diols and it has made the acetal linkage. Yes, it has made the acetal linkage. So our answer should have a furanose ring. Okay, so guys, as we can see in the D-mannose pyranose form, so in the pyranose form, acetone was not able to protect these two OH groups. Why? Because one was equatorial, one was axial. Okay, but if we are taking it over into the furanose form, then we can see both OH have turned together above the plane. So these two are 1,2-diol system and this is another 1,2-diol system. So our correct answer is option number C. Alright, why not D? Why not D? Because there is this thus OH group which is given over here on the anomeric carbon is wrong, because there is already this OH group. Okay, the anomeric OH group is already there, right? So that is why option number D is definitely wrong. Okay everyone, so now we are going to move further. Now we are going to move further and we are going to see another question from the same December 2015. So this question is asking us the major product A and B in the following reaction sequences are. So what are the major products A and B in the following reaction sequences? I hope that you will be able to answer this question. It is a very easy question, guys. Yes, you can come on the live chat. You can come on the live chat option, guys. So there is a live chat option. You can chat over there and I will be able to see your comments. Alright, so let us try to answer this question first. So as we can see, we are given 4 options A, B, C and D, and we are having 2 reactions over here. We are having 2 separate reactions. Okay, So the reaction which gives product A over here looks like it is a degradation reaction, isn't it? It looks like it is a degradation reaction. How? First, bromine and H2O is added. So guys, whenever bromine water is added to our glucose, or let's say our sugar, then we know only the alderic acid is formed. Okay, alderic acid, let's say glucaric acid, let's say some other other sugar may be there, which means only the CHO group is converted into C double bond OH. All right, and if that C double bond OH is reacted with calcium hydroxide, it is going to turn into calcium oxalic, basically the carboxylic acid salt, right? And after that we are using H2O2 and ferric sulfate. So we are using ferric sulfate over here. And guys, this whole reaction, as we, if you remember, it is called rough degradation. It is if you remember, it is rough degradation reaction. All right, okay. So now what about the other reaction? What about the other reaction? The other reaction is KCN it is using. So if the CN minus is attacking over the aldehyde group in the presence of HCN, it is going to first of all give you a cyanohydrin. It is first of all going to give you cyanohydrin, alright, and that cyanohydrin after reduction and hydrolysis is going to give you one more CHO group. So basically this CHO group turns into CHOH and there will be a new CHO group. So this is our step up reaction, and this reaction is called Kiliani-Fischer synthesis. Alright, I know that you know this reaction. It is called Kiliani-Fischer synthesis, okay, or step up reaction, and this one is a step down reaction. That is why it is a degradation reaction. Okay, so let us also discuss this. I have written the whole reaction for you guys. So this is where we start from. So this is where we are starting from. The CHO group over here, this is our molecule, right? So the CHO group can be, converted into COOH. Only the one group is converted by the addition of bromine water, right? It is a very, very simple because it is a mild oxidizing agent, right? So this might happen. Then the CH2OH group is left as such. Now if we are adding calcium hydroxide in the presence of H2O2, and this combination basically is used for rough degradation. Okay, so one of the this carboxylate group is just going to undergo dehydration, decarboxylation. Basically it is going to undergo decarboxylation, and this CHOH group, this whole CHOH group is now going to become our CHO. Okay, so this is a step down, and that is why called a degradation reaction. That is why it is called a degradation reaction. Okay, and so that is why what we are left over here is with these two OH groups, and these two OH groups, when they are on the same side, it will be erythrose. So I have just told you yesterday also that erythrose is going to help you now remember that both the OH groups are on the same side. Yes, both the OH groups are on the same side, so it is our de-erythrose over here. What about the synthesis over here? Again, as I had told you, first of all there will be the attack of cyanide on the aldehyde. We will be getting our cyanohydrin. Okay, then secondly, the reduction of cyanohydrin gives us imine, and then the the hydrolysis is going to finally give us one more CHO group, and this CHO basically becomes our H and OH. And guys, we have a possibility of formation of both the D-mannose and D-glucose, because we have discussed that these two are epimers. Alright, these two are C2 epimers. So if when the cyanohydrin is adding to this carbonyl group, then what usually happens is if there is a carbonyl group like this, okay, and if the cyanide is attacking, alright, then the OH minus can come over here also, and if the cyanide is attacking from this side, then the OH minus can go on that side also. Okay, so basically we can just, result it into this type of a cyanohydrin, or we can also result into this type of a cyanohydrin. Okay, so whenever the OH group is on the right side, then it is going to after oxidation of the cyanide group, it is going to give us the D-glucose, and similarly if this is what we are having, it is going to give us D-mannose, because both of them are C2 epimers. There is only a difference of carbon number 2, only a difference of OH group on carbon number 2. Alright, okay. Similarly, what we have is another question from June 2014. This question is asking toxicity of cadmium and mercury in the body is reversed by proteins. Yes, I hope that you are getting the question right. So the toxicity of cadmium and mercury in the body is being reversed by proteins, mainly using the amino acid residue. So which amino acid residue is used? Which amino acid residue is used for removing the toxicity of cadmium and mercury? So guys, cadmium and mercury both are heavy metals, isn't it? Both of them are heavy metals. Alright, so which of them is going to reduce the toxicity of the heavy metal in our body? Alright, yes guys, so right now I was just able to see all of your comments. It was not loaded before. Yes, Maya, Nazma, Maya, Mohammad Riaz, Surya, Zainab, Mudassir, Praveen, Saifi, Cherry, yes, Sanjay. Alright, okay, yes guys, you have been consistently giving correct answers. I was just now able to read your comments. Okay, alright, so now also tell me what is possible over here. Alright, okay, so yes, as we can see over here, yes, Sanjay, definitely. So as we can see, Sanjay has given a correct answer. The answer is cysteine. And why is it so? Why is it so, guys? Because if we look at the molecule of amino acid cysteine, then we will be able to see that in the molecule of cysteine we are having a side chain which has a thiol group. Okay, so this amino acid has a thiol group, isn't it? And the thiol group has a very high affinity for heavy metal, isn't it? Sulfur, it is giving soft interaction, guys. So have you studied the hard soft acid base theory? It was very basic and very easy concept. Yes, so if we are talking about heavy metals like mercury and cadmium or lead, okay, so sulfur is going to bind to them very tightly, and it is going to help them helps them remove the heavy metal toxicity, right, because of the soft interaction. Okay, so the proteins which are consisting cysteine, alright, so the protein whichever is having cysteine amino acid, such as metallothionein for example, so they are going to bind to these heavy metals and they will help them remove the toxicity. Okay, I hope that now the answer is clear to everyone why we are talking about cysteine. Why have we taken cysteine molecule? Yes, yes, Saifi. Alright guys, So what we are going to do right now is okay, all right, so we have another question. So guys, we have another such question from June 2014. Okay, try to answer me this question, guys. The pKa values of the following salt of aspartic acid are indicated below. So it is a very direct question, guys. The question is asking, the question has already given you the aspartic acid, right? The question has already given you the structure of aspartic acid, isn't it? Now, what is possible? Yes. So now what is possible? The question is asking the predominant species that would exist at pH is equals to 5. So what is the predominant species that would exist at this acidic pH? Okay. So yes, can anyone tell me if these are my options A, B, C and D? So can anyone tell me what is the correct answer? Yes, guys. Okay, so alright, so you are saying B, Safi. Okay, alright, so see over here. Okay, so let's see the pKa values of both the COOH group, alright. Yes, Rajesh, hello, just saw you, you're giving B answer, Sanjay C. Okay guys, so let's see what happens over here. Basically, the answer is option number B, and Safi and Rajesh, both of you are correct. Okay, so what happens is that first of all we have to see that what is the pKa basically. So at this value which is already given to us, so this pKa is very acidic, isn't it? It is very lower the pKa, higher the acidity, isn't it? So lower the pKa, higher the acidity. Same goes for this COH, lower the pKa, higher the acidity, right? So at pH value 5, the system is really very acidic, isn't it? At pH 5 the system is acidic, isn't it? And in the acidic medium, definitely what is going to happen? Okay, so in the acidic medium, usually what happens is in the acidic medium there is lot of H plus. All right, so there is lot of H plus in the acidic medium, and it is going to protonate all the species. But what we have to see is we have to compare these two values and we have to compare this value. So the ammonia, this NH3, it will be deprotonated at this 9.9 pH. So ammonia will, this group will be deprotonated at that high pH. But they can be the COH, both these COH groups can be deprotonated. They can be deprotonated at these pH also. Yes, and our pH is higher than that, isn't it? Our pH is higher than this value. So that is why both the COOH will be deprotonated at this pH, right? Even if it is an acidic medium, but these two are having pKa 3.9 and 2.0, and that is why comparing with these values we can say this pH is higher than the pH required for the protonation of these two carboxylate groups like this. So that is why we can say that both these groups are going to be deprotonated. All right, and that is why we can say our answer is option number B, which I have already told you. Okay. Okay, so guys, we have one more question. Yes guys, we have one more question, a very similar question from carbohydrate chemistry. So the question is asking the configurations of carbon atoms C3 and C4 in D-ribose respectively are. Yes. So the configuration of carbon atoms C3 and C4 in D-ribose. Okay, so what is the structure of D-ribose, that you have to know first of all, and then it is talking about C3 and C4. So let me just give you options A, B, C and D. So these are our 4 options, okay? So now you have to tell me which one is the correct option. RR, RS, SR, RR and S. Okay, which are our correct options. So guys, I have already written it over for you. What is D-ribose? It is a very simple carbohydrate, isn't it? It's a very simple carbohydrate. So the question is asking for C3 and C4 basically, right? So what is our C3? I have already shown it over here for you, so I'm not going to disturb much over this diagram. So what you can see is, you can see carbon number 3 over here and you can see carbon number 4 over here, alright? And guys, see, everyone is following some short trick for finding out the RNS configuration, isn't it? So to find out the RNS configuration, you must have some kind of short trick. Okay, but let us first give the priority order at this carbon number 3. Okay, so if you are giving priority, definitely the oxygen is given first priority over here. Then we move further to this carbon. This carbon is connected to one OH, one hydrogen and one CHO group. And this carbon is connected to H, OH and CH2OH. So basically we are going to give more priority to CHO than CH2OH. And that is why I have made it 2 and then 3 over here like this. Okay, and the hydrogen is definitely the 4th priority. So now if we see the clockwise rotation, it is 1, 2 and 3, it is anti-clockwise rotation. Okay, it is anti-clockwise rotation, alright? And that is why we can say, when the least priority group is on the horizontal position and it is anti-clockwise, it is going to be R. Okay. And similarly, if we look at carbon number 4, then also we can just directly give priorities, 1 to the OH, 2 to this whole group, we are giving 2 priority, then 3 to this carbon CH2OH and last 4 to methyl hydrogen. So 1, 2, 3, it is anti-clockwise, and the least priority group on the 4th position, anti-clockwise direction, definitely R. Okay, so C3 and C4 both are R configuration. Alright? Yes, everyone? Okay, so now we can say answer C is the correct one. Yes, Sanjay, you have given very correct answer. Really great. Okay, alright. So now we are having this question. Okay, so now this is also a very good question, guys. Okay, it is also a very good question from December 2014. The amino acid constituents of artificial sweetener given below are. So it is already told to you that it is an artificial sweetener. Okay, so when I just saw this question for the first time, I did not even have to look up on the structure. First of all, what I did was I just looked on the options. I looked up on the options, and if you know about the artificial sweetener, then very quickly you will be able to say what is the name of this artificial sweetener. It is very popular, guys. Try to tell me what is the name of this artificial sweetener. Yes, can you tell me? All right. So the name is aspartame. Okay. So the name is aspartame, and what is aspartame? Aspartame is an ester of, it is an ester of aspartic acid and phenylalanine. So even if you know the name already, then it is great. Even if you don't know the name, then also you can tell by just this is our peptide bond, isn't it? So this is our peptide bond, right? Okay, all right. So, and there is one more thing I want to tell you, that even if it is an artificial sweetener, but we don't want to consume any D acid. Basically all the amino acids which are present in nature are all L amino acids, right? They are all L amino acids, so we can just knock off option number A because we don't want to consume D amino acid which will not be digested. Okay, so definitely, as we can see, as we are disconnecting from here the peptide linkage, we can see this portion is our phenylalanine, isn't it? This is our phenylalanine, isn't it? This is our ester. Yes, so it is an ester of phenylalanine. And see over here, if we are having one CH2COOH group, if you are having acid in the side chain and there is only one CH2 group, then definitely it is our aspartic acid. Okay, definitely it is our aspartic acid, one CH2 one COOH. So you just have to remember this about the acids, basically all the 20 amino acid. Okay, something about their structure you have to remember, some short trick you have to make for remembering, right? So the answer is L aspartic acid and L phenylalanine. Did you also get this answer, everyone? Yes. All right, so as I can see, yes guys, you are getting the correct answers, which is really great. Okay, so answer is option number C. Okay, so this is what I have written. I have written it in fair. So if we are breaking aspartame, it is going to be the ester hydrolysis will happen and we can break from here to get L-aspartic acid and N-phenylalanine. So I've just written it over here for you, alright? Okay, so this is also a very good question, guys. Try to solve this. So, yes. Try to also solve this question. The question is asking, so it came back in December 2013, but it was a nice question, so I just took it up. So the question is asking the peptide A on reaction with 1-fluoro-2,4 dinitrobenzene followed by exhaustive hydrolysis. Okay, so what is 1-fluoro-2,4 dinitrobenzene? Can you tell me? 1-fluoro-2,4 dinitrobenzene, which is DNFB basically. What is the other name for DNFB? What is the other name? Yes, it is also commonly called Sanger's reagent, isn't it? Yes. Yes, yes, Surya, you're correct. I can see you're correct. Okay, so now what is the function of the Sanger reagent is to give N-terminal reaction. So basically if we are having a protein or a peptide chain, it is going to react with the N-terminal amino acid. Okay, alright, so let's see if we get any hint. So on the reaction of peptide A with our Sanger's reagent, followed by exhaustive hydrolysis. Okay, exhaustive hydrolysis, which means we are breaking the other peptide bonds by hydrolysis. It gave us phenylalanine, alanine, serine, and N,2,4-dinitrophenylglycine, which means that on the N terminal side we are having which acid, guys? On the N-terminal side we can say we are having our glycine, isn't it? So on the N-terminal side we are having glycine. Okay, then after, on the other hand, peptide A, after two cycles of Edman degradation gave phenyl aniline and serine. So basically these two are still connected. So phenylalanine and serine, these two are connected. So again Edman degradation is also going to react the N-terminal acid. Okay, so after two cycles of Edman degradation which means there are two amino acids which have already degraded and these two are remaining as a dipeptide. So in the option, guys, we can see that there, in all the options, we are having phenylserine together like this. Okay, but we can confirm from the first option, from the first test, we can confirm there is glycine in the beginning. Yes, and after 2 cycles, which means after removing glycine and after removing alanine, then there will be phenylserine. So answer is option number C. Yes, I hope that all of you are able to understand that after 2 cycles it is given. So after removing the glycine first in the Edman degradation, and then after glycine removing the alanine first, then we are getting this phenylalanine and serine. Alright, so definitely these two are removed by Edman degradation, so that is why our answer is option number C. Okay. Yes, guys, all of you are correct, as I can see. So I have just written all the explanation for you, that this is Sanger's reagent and it reacts with N-terminal amino acids and so on. So here I've just written all the explanation. Okay. So if you are able to download the file, then please download it, because then it will be you will be very clearly able to watch it, right? Okay. So here we have one more major question. So guys, here we have one more major question from December 13 again. Okay, so the question is asking, the major product formed in the following reaction sequence is. It is a very nice question, guys. It is a very nice question. Try to answer this question as well. Okay, so what do you see as such? What do you see? We see a D sugar, we see a pyranose, we see a pyranose sugar, isn't it? Yes. So if we see a pyranose sugar, we had also talked about the protecting groups, right? We had talked about acetone, isn't it? We talked about acetone, that it is protecting 1,2-diols. Acetone is used to protect 1,2-diols, and PHCHO is used to protect 1,3-diols, isn't it? PHCHO is used to protect 1,3-diols. Okay, and if you have known this reaction, then it is really great, because now what happens is, okay, so where is our 1,3-diol? Where is 1,3-diol? 1,3-diol is over here. So this is our 1,3-diol. Okay, so there is a difference of 3 carbons, 1, 2 and 3. There is a difference of 3 carbons, so this is our 1,3-diol. Okay, then the what are the options? In option number A, it is protecting 1,3-diol. In option number B, it is protecting 1,2-diol. In option number C also it is protecting 1,2-diol, and in option number D also it is protecting 1,2-diol. So guys, this question was so easy that even only if you know the first step, then only you can answer the question, isn't it? You need not go further. You can just see the first step itself, that it is going to protect the 1,3-diol, and then only you can answer this question. Okay, but we are going to go further and we are going to see what is happening. Alright guys, so this linkage over here, this is our acetyl linkage, isn't it? This is our acetyl, or let's say hemiacetyl linkage, right? The OH group, and this is our ROR group, right? Like this. So this is our acetyl or hemiacetyl linkage, so it will be broken in the presence of acid, right? Now in the next step we are having NaIO4. So this sodium periodate is used for breaking 1,2-diol. It is for breaking 1,2-diol. For example, let's say we are having glycol. Okay, so if we are having glycol like this, then it is going to break glycol and it is going to oxidize. Alright, so it is going to oxidize into HCHO and HCHO over here. So basically it is NaIO4 breaks it breaks 1,2-diols, right? So in the molecule, can we look for 1,2-diol? Do we have a 1,2-diol? Yes, these are our 1,2-diol, isn't it? So if the PHCHO is protecting these two diols, then these two diols are free to react with NaIO4 and they are going to, NaIO4 is going to break the 1,2-diols over here, right? And after that it is going to form CHO over here. Yes, it is going to form CHO over here. So let me just quickly show this to you that after the molecule is protected, after these 1,3-diols are protected like this, NaIO4 is going to break this bond like this and it is going to oxidize this part and also it is going to oxidize this OH into CHO, basically aldehyde, right? And that is why we are given NaBH4, because it is going to reduce this group. It is going to reduce this group into CH2OH like this, okay? And the other group and the other OH group which was here, it is only forming the hemiacetal linkage. So under these conditions it is also going to open up. All right, so that is why this is our correct answer. All right, so our correct answer is option number A. Okay everyone, so I hope that you were able to understand the questions, the solution to the question. I hope that you were able to understand the class and take something from the class, right? So guys, I would request you to visit the profile and follow for regular updates if you want to on the Unacademy platform, right? And if you also want, then you can visit my free video courses. All right, visit my live or let's say special courses because there are a lot of classes that I have taken on previous year question, right? And I hope it will be helpful for you. Thank you so much guys. Thank you Sanjay, thank you Saifi, thank you Surya, thank you yes everyone. So basically guys, you have been very actively responding. Thank you Rajesh. Yes guys. Thank you Cherry. Thank you Praveen. Thank you Nazma, Zainab. Alright, Mohammad Riaz. Thank you Maya. Thank you everyone. Alright guys, I hope I'll see you tomorrow. Okay, so tomorrow I'm having a class on the same time, 8 p.m. on YouTube, same time. So tomorrow we are basically going to discuss about the organometallic reactions, right? So we are going to discuss alright guys, thank you. Alright guys, and also there is one thing that I would like to tell you. If you visit the Unacademy platform, if you like the classes, okay, first I would suggest you to watch the free live classes, okay? The free live classes, please watch them, and if you like the content, then you can subscribe. And in the beginning of the video, I have already told you about the 1 month, 3 month, 6 month, and 12 month and 24 month subscription packages, about the plus courses. So there are a lot of plus courses by a lot of educators in which all are live and structured. What are structured? Basically it is a regular course and on the same timing it is happening, and also there are doubt clearing classes, weekly quizzes, which makes it very interactive, right? And from my side there is also a WhatsApp support group, okay? So there is a WhatsApp support group in which you can put in your doubts, right? And I will try to see them in the doubt, solve them wherever possible, whenever possible, right? Alright guys, so visit my profile, and if you like, then subscribe using my referral code, which is Jagriti S, okay? And thank you so much for watching thank you so much for coming to the class. If you please like it, please also subscribe to the channel and also share it guys. And if you follow me on the Unacademy website, then you will be able to get regular feed about the courses. Thank you so much for watching, guys. Have a good night. Have a really good night, guys. Okay.